There are two different methods of subtraction I want to talk about in this video. One is using compatible numbers, and what this is trying to show in the picture on the left here, or the diagram with the number line and everything and the subtracting in steps, is that kids are going to know what 14 minus 4 is pretty quick, right? They're going to say it's 10. They're trying to take that information that the student has and take away a little bit more. Right? So they're trying to say, hey, if I have 14 minus 4, it's a 10. 14 minus 6, hey, I'm going to take away 2 more, so I'm going to get an 8. And that's what the number line does show there. And the student, they're trying to show what the student would be thinking if they were doing that in their head in this particular manner. Again, if you're like me and you went to school, elementary school in the 70s or 80s, you probably just memorized that 14 minus 6 was going to be an 8 and didn't think through this. However, it does come in handy a little bit later when you start to do other kind of problems and you grab those compatible numbers. The other method, they don't use the terminology, but it's called equal differences. At least they don't use it on this page that I could see anywhere. And they call it using the tens facts. And what they're trying to get you to do really is to write an equal difference. So what they're basically doing is saying this: if I subtract 6 from 16 and I subtract 6 from the 9, then I would have a 10 minus a 3, which is a 7. And so that's obviously the answer, right? 16 minus 9 is going to be a 7. Equal differences don't mean that you always have to go down to a 10 or down to a 20 or some multiple of 10. You can go the other way. And many students will actually do this. They'll say, oh, 16 minus 9, that's going to be the same thing. What if I add 1 to both? And I make that 9 into a 10, right? So that's going to be a 17 minus a 10. That seems a little bit easier to me for this particular example. And I didn't use a quote unquote tens facts, but I used something, similar, looking at equal differences. It doesn't seem very important for small numbers like this, but when they get larger, it does help out a little bit. If you were trying to do 74 minus 26 and you did not have a calculator, you could do the same thing, right? You could take 4 away from the 70 and 4 away from the 26, and you would have 70 minus 22. Now in your head you would say to yourself, hey, I know that 70 minus 20 is 50, but oh, I have to take away 2 more. Oh, isn't that exactly like the first example I showed you? So you're going to have a 48. You can also do this. You can say, hey, instead of making the 74 into a 70, what if I made the 26 into a 30? So I could add 4 to both of these. And so that would look like 78 minus 30. Oh, again, that's pretty easy to subtract. I'm going to get a 48. Last thing is this example that I saw from Facebook from a different person. Actually, a math teacher had posted this. And it is this: instead of looking at 5,000 and subtracting 2,384, which can be a beastly problem, right? Look at all of the borrowing that you have to do to make the right make the right number of units there so that you can actually subtract, right? Because you can't take 4 away from 0. You'd have to take 4 away from 10, and you go over the tens, you borrow, etc. You have to keep going over all the way to the thousands. And so this, is quote unquote revolutionary from Australia, which it really is just common differences. So this person said, hey, what if I subtract 1 from both the numbers? So again, all we did was we made this into I don't want to say common difference, I meant to say equal difference. Right? So this guy is just an equal difference. You made this 5,000 into 4,999. You made the 2,384 into 2,383, and now it's a cinch to subtract. And you see the little part down here where they say no regrouping. Here, I'll just make it a little smiley face there because that does seem to work out quite well. So some of these little tricks can be applied to make problems a little bit easier. It's not universal though. Of course, you can't apply every trick to every single problem. Thanks for watching.